No, that's disappointing. I did.
So let's get the big picture part of this out of the way first. When you guys have been solving equations, we don't talk about this a lot, but what you guys have been doing is you've spent the first 4.5 weeks with me finding a single number that makes an equation true. It's a very powerful thing you're doing.
7 is greater than.
-6.
Oh, I mean, -6.
Mhm.
Greater than 10.
Yep.
So I think there are multiple numbers that.
So, like I was saying, when you guys have been solving equations, you guys have been tracking down a single number. That's what's neat about linear equations is that they're so like closed and compact. At the end of a problem, when you say x is 5, you're stating to the world that 5 is the only number you could change x into that would make the left and the right side equal each other. With inequalities, it's more open-ended than that. There are quite literally infinitely many numbers that can make this true. So with equations, there's one answer. With inequalities, there are infinitely many. And you clearly don't have enough time in an infinite number of human lifetimes to write down all of the numbers that would work. So when we solve inequalities, we solve them just like equations. So we'll talk in a second about the signs and all you've probably learned some ridiculous things about like the inequality sign being a chomper that eats the bigger thing or whatever. We're going to memorize it. Like we're going to remember that because like we're all big kids. Like what's that round thing on the wall back there with the numbers? Yeah, like if you can look at that and tell me that that's a clock, what is this called? That's my hand, right? What's this called? That's a thumb. Like you've demonstrated throughout your 14 or 15 years that you can memorize what things are by looking at them. So my expectation of you will be that you can memorize that when you see that, that's called a greater than sign, right? You're not going to draw teeth on it and go, okay, it's an alligator and it always likes to eat the bigger. Like we're not going to go down that road. That was fine in like 4th grade, but we're just going to say, you know, that thing right there, that sign, that's called a greater than, and the one when it points the other way is called a less than, and that's it, right? And you slap one of these on the bottom. What do you add? Or equal to. Yeah, it's so greater than or equal to, less than. We're just going to memorize it, right? We're not going to play silly games about alligators and stuff like that. So anyhow, let's solve this problem like it were an equation. If that greater than sign were an equal sign, and we just approach this with all of our training, which you guys, by the way, again, are good at, what would we do?
Add into those.
We would not add the 10.
No, because they have to. So you add the 6.
Right. And it's not because of that. It's because we want the one that's next to our x, right? So we're going to add 6 to both sides like this.
16.
And we're going to get x. And this time, normally what I say to you guys is to bring down. So normally I would say bring down your equal sign. In this case, we just take this, what's called an inequality sign, and we copy it down like this. And then -10 plus 6 is -4. So in the past, what we would have said is that x just has to be -4. What we learned from this statement is that x actually can't equal -4, but x can be any number that's bigger than -4. So we're gonna graph these right away on day one. We're gonna have the habit of not just stopping. Like if this were an equation, we would have put a box around it and been like, boom, we're done. With inequalities, we want to illustrate what this looks like to somebody. When it's just a point, it's not very interesting. But when it's an infinitely large container full of points, we want people to see that. So the way we graph inequalities is we start by just drawing a line, and we put arrowheads on both sides. And I don't know what experience you have with number lines, but you might have had teachers in the past that made you write a whole bunch of numbers. All I ever want on your number line is the number that we care about, what I call the boundary point. So in this problem, I'm saying to you that x cannot be -4, but that's where the solution set starts. And so to illustrate this, I say to people, right on my number line, I put a circle, but I do not color it in. Why? What am I trying to say by not coloring it in? Is x allowed to equal 4, -4? If I put -4 where this green arrow is pointing, is this a true statement? Is -4 greater than himself? That's what the hollow circle is for. So by putting a circle on your number line and making sure you don't color it in, you're telling the reader of your graph that that number doesn't count. But where are the numbers that do count? Where are they? Give me a direction.
But
To the right. Numbers get greater than a boundary as we go to the right. So the way we illustrate this on a number line is we shade the number line like this and just color right on top of the line. And then to finish the job, you do have to put a nice big pronounced arrow at the end. So that's what these are going to now look like. We're not interested just in the one point. We're interested in where are all the points that make this work. Okay. Now, I haven't gotten to the rules yet. So this next problem is going to give me my first opportunity to tell you rule number 1. So this next one is -12 is greater than or equal to. You'll sometimes hear me for this use the words at least. I'll try to throw that in. I just want you to be aware that that's a good like English sort of math equivalent of greater than or equal to. Okay, so -12 is at least x divided by 4 minus 9. And we just have to convince ourselves, just treat it like an equation, just treat it like an equation. Everything will be just fine. What do we do first? We add that 9, right? And it's not for any other reason than that he's over here on the side with my variable. He's a straggler, so he's got to go. So we're going to add that 9 across like this, and we're going to cancel these out, and we're going to bring down our variable chunk. We're going to bring down our inequality sign, and then we can't escape the basic math. What's -12 plus 9? Good. Again, we're still just in equation mode. How do we know to solve an equation like this? Yep. So we're going to put on our monster parentheses and multiply by 4. And we're going to say it just feels like we're doing the same stuff we've been doing, right? And then we're going to bring down our x. We're going to bring down our inequality sign. And then we're going to do 4 times -3, which is -12. Any questions about that? This answer is bad. And I will tell you now, and what's nice is I'm working with such a smart group of kids this year that this is, I think, going to make sense to you on the very first try. What I see, and I've got like thousands and thousands of instances of watching kids do this, and it breaks my heart, is I've watched kids make the solution. Don't do this, by the way. I'm going to mess up on purpose. I've seen kids go, okay, someone say this sign to me out loud. What does that say?
greater than or equal
That's
to.
greater than or equal to. And so I'm going to color in the circle this time by I want to tell someone that -12 is in the club. He counts. He's less than, greater than, whatever himself because of the equal sign, right?
Mhm.
And then because it says greater than, I'm going to shade to the right. And here comes rule number 1. And if you just would follow this rule, I'd be really grateful because then we'd never miss points for this. This is a terrible graph. Can someone read the green box to me?
-12 is greater than or equal to x.
Correct. Which leads you down the road of still maybe some of you wondering, what's he talking about? I don't see anything wrong with that graph at all. Can someone now read me the green box, but from right to left, please?
X is less than or equal to -12.
There it is. You won't often know the real identity of an inequality unless you adhere to rule 1. And rule 1 is this: variable should always go on the left. And I say with equations, you've seen me do it 100 times. With equations, I don't care if I write 5 equals x and you write -10 equals x. No one cares because it's equals, it's 1 point. But when we talk about relativity, greater thans and less thans, directionality starts to matter. right? And so I don't want to view that green box as a greater than sign. I should always say, where are my x's? And if I read it like Seth did the second time, it quite literally says that x is less than or equal to negative 12. So this answer that I have in the green box is pure dog water garbage. What I'm going to do and what you're going to do every time is we're going to force the issue. And if the x winds up naturally, like organically on the wrong side, we're just going to flip it and we're going to write it the correct way. So the actual answer to this problem is x is less than or equal to negative 12. And that matters now, as you can see, because when we go to make a graph, we set our boundary point and we still color in the circle to tell people that, hey, that point's in the club. But now we understand that it's x's that are less than, not greater than. That relativity really does matter. And there's, I'd say, a 50-50 split. There's about 50% of students that can write it the wrong way, the backwards way, and still understand and graph it right. I don't like those odds, though. I feel like we should fix it so that we're at 100%. And we'll always be there if we make sure we always put our X on the left, okay? So that was rule number 1. This next example is going to teach you rule number 2. And then after that, everything else is just icing on the cake, okay? Again, no rule yet, just basic algebra. What do we do first? Distribute. It's always a great answer, right? We're going to get rid of those parentheses. 3 times 4 is 12. And then the second half of this is going to stay minus because we don't have to change the sign. 3 times x is 3x. And we're still just in equation mode. Right? Nothing to it. What do we do next? Subtract 12 is exactly the right answer. Again, we've done hundreds of these, quite literally hundreds of these by this point in the year. We're going to bring down the negative. It used to be called a minus, but when it comes down, we have to rename it as negative 3x is greater than 3. And I'm about to do something, and I want you to tell me if you think I messed up. I'm not going to tell you if it's a mess up or not this time. I'm going to go like this. Divide. I'm going to bring down the x. What? Good?
No. Yes.
I mean, I did something, right? And that should have red flagged you right away. Yes. And some of you know this rule. You come at me from different places. Like you hear teachers say different things. You come, maybe some of you from different schools. I don't know, but some of you know the rule and some of you don't. I did not mess up. Rule number 2 is this. When we're working with inequalities, if you multiply or divide by a negative, you switch the sign. Greater thans become less thans. Less thans become greater thans. So I did not mess up. I did that on purpose because that red number is like, whoa, 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 that's a negative. If I divided by negative, then notice that the greater than got switched to a less than. You now know all the rules of solving inequalities. Rule 1, please make sure your variable always migrates to the left. Rule number 2, make sure when you multiply or divide by a negative that you switch the Pac-Man, flip him around. So this one's good to go. I don't have to worry about rule 1 because the x is already on the correct side. So if we go to graph this, we just make a little number line like this, put arrows on it. I only need one number on this, and that's the boundary. Open or close circle. Keep it open because I don't want -1 to be in the club. And where will I shade? To the left, because this says is less than. And numbers get less when you go to the left on the number line. Put a big chunker arrowhead on there, and that's it. Let's take a look at something. I hope this inspires conversation. Sorry about the fly, guys. He will officially get swatted after this is over, I assure you. So, we spent days on this, variables on both sides. What would your math teacher say to do? Combine like terms, distribute all that, but there's none of that to do. So now that we're at go time, what would be my opinion on who we should get rid of? Right. Subtracting 2x is exactly what I would want you to say, and it's exactly today what I don't want you to say. And what's weird about this is, okay, so if we subtract 2x, why is that good? Why is that good? Because it keeps it positive. And we all know that 2 is smaller than 6. And as your annoying teacher told you, if you always get rid of the smaller one, you'll always have a positive number. Why is that bad in this case?
Because only X is on the end.
Because the X goes to the wrong side. And my experience tells me that we just should not put ourselves in that position. So despite all the stuff I tried to hammer into you for the first month of school, I'm going to kind of pull back those reins a little bit and loosen them up and just say, let's always make sure if we have a choice, let's put the X on the right side, the correct side, the left side, right? So if you want to subtract 2 and just switch it later, you can. I'm going to kind of change what I do here. This is always the day where I kind of reveal my true colors. And I say, you know what? I honestly don't care. I'm going to subtract 6 because I'd rather have my variable on the side I want than have to deal with it later. And we're all big kids, like we can handle negatives, right? So let's agree that when given the choice, we're going to move the variable from the right side over to the left so that at the end, it's good to go. So let's get rid of these. How many X's will I have on the left? 2 minus 6 is -4. And I did make a negative. We saw that coming, but we're not scared. Chickens, saying our first rodeo, right? Is that what they say? So fine. What do we do now? Add 10. Work our way down. We're left with -4x is still less than or equal to what's 12 plus 10? 22.
Sorry, that really looks like a negative given time.
What are we going to do now? We're going to divide. And I'm not scared because I know rule 2. And it's not that much to ask that you memorize a couple little simple rules, right? It's part of math, really. It's probably math is more like that than a lot of classes where you just got to practice and memorize little nuancy things. I'm going to divide by a negative. So my radar goes off, my flag goes up. I'm like, I know what to do. I know what to do. I'm still going to do my algebra, but what am I going to do now?
Well,
I'm going to flip the Pac-Man, right? Because I divided by a -4. And so I'm going to switch my less than to a greater than or equal to. And we're not scared. We're not going to type this in and go, our decimals okay? We've heard that lecture before. What are we going to write? First off, is it positive or negative?
negative.
Negative. And what's 22 over 4 become? That's it. And I hope I'm getting that stuck in you that this is not the end of the world. Fractions are just fine. Improper fractions, whatever. Who cares? Just reduce them. And so I don't have to worry necessarily about what that is. It happens to be -5.5, but for my purposes, I'm just going to sketch a number line. I'm going to mark right in the center of my number line, -11 over 2. You don't need any more numbers than that for me, not for this guy. I'm going to boundary it. Do I want it open or closed?
Close.
Closed this time. I want to show the world that that point counts. He's in the club. He's the solution because of the or equal to clause in the contract. In which way will I shade? Correct. So we will shade to the right. That is 4 out of 7 examples, and I know better than to press my luck. So what we're going to do is we're going to just take some time off from math. We're going to end it there. And then Monday, I'll finish this up and we'll get to work. I'm not even going to give you the next assignment. I don't see the point. Okay, so now you know the basics. Treat them like equations. Put the variable on the left, and if you divide or multiply by a negative, switch your Pac-Man.
That's all I. Variable.
Do I need to keep these?